Hi, in this video we are introducing a new concept, the shear formula due to the bending. So that's in chapter 7 of Hebler's book. So in the last one, we learned about the bending stress. And we know if you look at the cross section, if it's a rectangular section, and you realize this is going to be the neutral axis, and the profile for the stress looks like this, right? And we realize in the neutral axis, the stress there, normal stress is 0, the bending stress. And then with this formula, we know when y increase and your sigma increase, so it's a linear relationship. However, this new topic, in this new one, we're not looking at bending stress. Bending stress is normal because it's, perpendicular to the cross section. We're looking at the shear. So in a shear, it's taking up a completely different formula. It's look like this parabola shape if we're looking at this cross section. So what that means is in this is going to be our neutral axis. And you realize at neutral axis, this shear stress, shear we're going to use in the symbol tau, right? No longer sigma anymore. Tau is going to reach its maximum at the neutral axis. However, where at the top and the bottom, where at the edge, you're going to get tau to be equal to 0. This is exactly different from bending flexural stress. It's the opposite of it because over here, you get sigma equal to 0 at neutral axis. However, here you get maximum of shear. While you are getting the maximum of your compression and tension stress, you are getting shear to be here at 0. So that's the difference. So I want to look at them side by side to realize that. So what's going to be the formula for this shear stress? I'm going to directly write it down. There is derivation, but here we're just going to come up with a formula. This tau is going to be equal to this V. V is shear. So that's going to be the maximum shear you got from no shear bending diagram times this Q. And Q here, I'm going to use maximum. We haven't introduced Q yet. We will be soon. This is going to be neutral axis. And this is going to be our B. So let's go ahead, explain what they are. So this is going to be maximum since we're using maximum value. Okay, so Vmax is maximum shear. That's self-explanatory. So that's maximum shear. That's from our load shear bending diagram to find that maximum point, the highest point on the shear diagram. So what's our Q max? Q is moment of area from, and I'm going to write it down out, moment of area out from point of interest. And I know it's still quite big. No worry, I will explain that through an example. And what's our B? B is going to be the width of the beam at point of interest. Why have to be at different point of interest? Because, for example, if I have this rectangle cross section, at this point A, you're going to have shear to be 0. However, at this point B, that's a point of interest, the width is going to be this point, right? But if you have some shape that's weird, like for example oval shape, and this is point B, so the width of the B is going to be this width, right? Which is quite different from the base here. So it's going to be width of the beam at that point of interest. Okay, so knowing that, we're going to spend some time on this Q. What is Q? Q is moment of area. We're talking about its moment of area. Let's use this example using the rectangle. Imagine this is going to be Q formula. Q is going to be equal to the area, right? Since it's moment of area, it's area times some distance. Now let's look at it. And I'm going to write down AQ and a YQ here. So for example, this is going to be my point of interest. And this is going to be our neutral axis going through the centroid. And its moment of area at this point, and it's out from the point of interest. That's important. So what I'm going to do is I'm going to highlight. This is going to be the moment of area out from the point of interest. Do you agree? Because it's from here. This is point of interest. It's out, so it will be this area. Okay, knowing that, we're going to make some values here. And we're going to explain this is area. Now what is y? Y is a distance. So y is going to be the centroid of this area, this green area, to neutral axis. So in that situation, if I were drawing that y, that would be, oops, what did I do? From center of this green area to neutral axis. Okay. So if I were to draw that y for this one, it's the centroid of this green area will be that dot. It's going to be from here to my neutral axis. That's going to be my YQ. And this area will be AQ. All right. So knowing that, hopefully it's getting better. I'm going to make a more specific scenario. If now my point of interest is right at the neutral axis. That is my point of interest. I want to know what's going to be my y, what's going to be my q at that point, moment of area of that point. So I'm going to use this formula, AQ times YQ. And from this point of interest out from my point of interest, that's going to be my area. That's going to be the area out from point of interest. So in that situation, oops, if I know this is B, this is H for this rectangle. So this green area will be half BH, right? Then how about YQ? Let's go ahead and label that. This YQ is going to be this green area centroid to this neutral axis. So will be that value. For this situation, it's going to be quarter of H. Do you agree? Because this top one is half H. That's going to be. So here I'm going to make a note. If point of interest is at neutral axis. Okay, for this scenario. Now I'm going to put YQ as quarter H. In that situation, my Q will become half BH squared. Okay, then now let's look at another scenario. If my point of interest is at the top point, at the top edge. So if POI is at top or bottom of this rectangle. In that situation, what will be my area out from this point? you'll realize it's just a line. It's a single line. So in that situation, my area will be 0. Since it's a line, there's no area. Even though there's a YQ, because the line is going to have its centroid. It's from here to where? To the neutral axis. So that's going to be my YQ, which is half h. However, I still get 0. Now think about it. So now we understand that's moment of area. It's like area times the distance. Area times the distance is from this centroid of area to neutral axis. So knowing that, then we can go back to this formula right here. This tau shear stress is V maximum times Q max. So I'm actually going to write it down right here. So tau is going to be Q, VQ, IB, right? So imagine if this point of interest is at neutral axis, this scenario. Then we can put it in there. I'm going to label A and B. If it is A, my tau is going to be equal to V. And here, I'm going to use maximum V from the low shear bending diagram. And my Q for that situation is this value, 8BH squared. Because at that point of interest, you already figured out the Q is 8BH squared. And then divided by I. What's going to be my I for this one? For moment of inertia for rectangle, that's going to be 1/3. Or no, that's not 1/3, isn't it? It's 1/12. So it's 1/12 BH cubed. Then times my B. Okay. Then if it's B, if point of interest is at neutral axis, what do we get? Even if we get a maximum shear, remember the maximum shear is gonna be the location on the beam. Like for example, x equal to 2, that's gonna be at the midpoint, you're gonna get maximum shear. And then, however, this point of interest is basically when you slice it down, you get this cross section. For example, you get a rectangle, and at the rectangle, different points are going to have a different shear stress. Okay, if that point is at shear stress, we know that Q is equal to 0. Put 0 in there, and then you can still put, moment of inertia and B, all those here, and you realize what's going to happen. Your shear is equal to 0. That coincides your shear profile right here. So remember, shear is going to be equal to 0 at neutral axis. I'm sorry, shear is going to be equal to 0 at the top or bottom edge. That's going to be equal to 0. However, at neutral axis, you reach the maximum because this value y, this value, the Q here, that gives you the maximum value if it is at centroid. Okay, so that's a lot for this problem. For this one, and now I'm going to review this one with one more thing for this video. If my shape is actually, I'm gonna put that in the next video. Okay, so all right, bye now.